This is Unit 1A. It deals with energy, heat, temperature and state. The two key ideas we're dealing with here are matter and energy. Now, matter is just a word for stuff, and stuff is made of atoms joined together to form molecules, and together we call those two things particles. The key idea is that particles have kinetic energy, and this is the energy they have because they're moving. We can't see it, but they're either flying around, or they're jiggling around a point, or they're mingling as they do in liquids. Now, if we consider a particular sample of material, say a bucket of water, it'll have a certain amount of total kinetic energy. There will be a total amount of Ke in those particles, and we call that concept heat. Now, we also have the idea of temperature. Now, temperature is the average heat per particle, and that's the crucial difference. It's per particle. We have the Celsius scale, which we're quite familiar with over here, to measure temperature. Now, over here on the right of your picture, we have a little illustration of the difference between the two. If we consider the heat that there is in a pool, there'll be quite a lot of it because there is a lot of water there, even though the temperature is a relatively low 25 degrees or so. And that's in contrast to a kettle, where there are few particles relative to the swimming pool, but each particle has more energy. We can think of China, a very large country, lots of money. We can think of Monaco, which is a very small country, but it has more money per person, and that's the key idea. So back to our central concept here, heat. Heat basically does two things. It either raises temperature or it breaks bonds. So raising temperature is what we understand quite readily. If we want to know how much energy we need in a particular situation, we need to know the mass that we're dealing with. More mass, more energy. We need to know the temperature change, but we also need to know what substance we're dealing with. So this number here in the middle is got to be specific to a particular material. We also have latent heat, which is the heat that breaks bonds. So here we can see temperature rising and then it pauses. Why does it pause? Because the bonds are being broken. So we can see here ice at the bottom. The energy is breaking those bonds and making water here. If we want to know how much energy we are going to need in any particular situation, we need to know the mass. So the more stuff we have, the more energy we're going to need. And again, it's got to be specific to the material. We can see in this little graphic here the idea of energy flowing towards the ice cube. A very similar thing happens here when we have boiling. Again, we have bonds being broken. They aren't shown here, but there are bonds between the water molecules, and if they have enough energy to break those bonds, then they turn into gas molecules there. We also have the thermogram here, which is infrared waves turned into colors to make it more easy to see what's going on. Finally, we have the idea of energy loss, so cooling. We've got two contrasting containers here, one that's very well insulated and one that's not so well insulated. In both cases we have a steep downwards gradient to begin with. Both level out, but the better insulated one takes longer to level out. So to summarize then, heat, central concept, is the total kinetic energy of particles, and if we're interested in describing temperature, that's the average heat per particle, and heat can also change state.